In this video, we'll compare Go with some other common programming languages. First, Java and Go share some similarities. They're both partially, at least, inspired by the C language syntactically, and they're both statically typed. They're both excellent for server-side programming, and they both automatically perform garbage collection. Now, where we get into the differences. First, with architecture, Go is a compiled language and produces a compiled binary. Java uses a Java virtual machine to interpret compiled code. Although this is really good for portability, it slows Java down compared to Go significantly. As far as readability is concerned, Go is designed to be simple and readable, generally considered to be more compact and precise than most languages actually. It automatically, for example, does away with unnecessary parentheses, but it is also less forgiving. Java has decent readability, it's just not as compact, simple, or as easy to read as Go. For programming type, Go is a statically typed, multi-paradigm programming language supporting functional, procedural approaches, and while Go is not specifically an object-oriented programming language out of the box, it does provide ways to emulate object-oriented programming. Java, however, is statically typed and an object-oriented programming language. In terms of age or maturity, Go is newer, so it has a less comprehensive library than Java and library support in general, but it is managed and maintained by the Go team, so all packages, all libraries are tested, approved, and working. Because Java is an older and more mature language, it enjoys a huge community and a tremendous level of library support. For error handling, in Go, errors are values. So we can return them, for example, from functions and then decide what to do with them. But what we're actually talking about here is exception handling. So in Go, defer, panic, recover is the method that we use for exception handling. Defer is a keyword used to convert a function into a special type of function that essentially gets evaluated at the time it's called, but only executes once the surrounding function returns. Panic is a built-in function that stops the ordinary flow of program execution and begins panicking. It can be invoked programmatically or by the runtime. Invoking a panic causes any deferred function calls on the stack to be executed, then flow returns to the caller still in panic mode and continues on up the stack. To return to normal program flow, the built-in recover function can be used. But in order to use recover, it must be called inside a defer function. Similarly, panic may be captured only if the function already has a defer call. Java uses the classic try-catch approach. In the try block, we specify code that we want to monitor for errors while being executed. This is typically some important or risky operation, and we need to be able to handle it. Meanwhile, code to handle exceptions is written in the catch clause. Here, we can define a block of code to be executed only if an error does occur in the try block. The try and catch keywords come in pairs. An optional finally clause is executed regardless of whether an exception was raised or not, typically to clean things up or release external resources. Regarding concurrency, Go has excellent multi-threading capabilities for handling multiple concurrent processes. It was designed, essentially, to leverage newer technologies, and its concurrency model is one of the best. Java also supports concurrency. With Go, reflection is technically supported, it's just a little more difficult in practice, and Java also supports reflection. Now, Go versus Python. Go, again, is a compiled language, so typically it's faster than Python, but that depends on a number of factors, but typically it is faster. And again, Python's an interpreted language. Regarding readability, Go is designed to be simple and readable. Python is overall very user-friendly and very readable. For programming type, Go is a statically typed, multi-paradigm programming language that supports functional procedural approaches and again also does support ways to emulate object-oriented programming. Python is a dynamically typed object-oriented programming language, but not strictly object-oriented programming. It's also a very high-level multi-paradigm language, and as such, it does support functional and procedural programming as well. Regarding maturity, Go is newer. We may see less comprehensive library support, for example. Python, on the other hand, is a more mature language It's also carved a niche for itself in data analytics, data science, machine learning, and AI programming. For exception handling, Python uses a try except finally approach, which is very similar to Java's try catch finally. For memory management, Go fully supports memory management like garbage collection. Python does as well. For concurrency, Go has superior multi-threading capabilities, but Python does not support built-in concurrency. Reflection is supported by Go, and Python is itself a reflective language. Now, Go and C++. Go and C++ have some shared aspects. So, for example, they're both statically typed and they're both compiled. Although they are both compiled languages, Go has a significantly faster compiler than C++. C++, on the other hand, produces programs that are relatively very fast. So a little bit faster than Go, but Go compiles faster. As far as readability, Go, of course, high readability. C++, not so much. It's considered a mid-level language, so it's not as intuitive as higher-level languages like Go. Therefore, more complex to code in as well, so you can expect slower coding speed. Go, again, statically typed multi-paradigm programming language, whereas C++ is a statically typed class-based object-oriented programming language. Go, of course, is a newer language, and C++, being an older language as it is, benefits from a huge community supporting it, has a large library and major library support. For exception handling, Go uses defer, panic, recover, of course, and C++ uses the try, catch, throw approach. Go automatically performs memory management like garbage collection. C++ does not. As for concurrency, Go has excellent multi-threading capabilities. C++ also supports concurrency. And with reflection, Go is reflective, and C++ is also somewhat supportive of reflection in that you can perform some level of meta querying of objects, and it does support type introspection. Now, Go and C#. Many shared aspects here. Both are compiled languages. Both can target multiple platforms. Both support garbage collection, although C#'s method of garbage collection does seem faster. They both support modules, which are known as assemblies in .NET. They both support asynchronous execution, although Go's implementation is faster. And they're both designed to help programmers develop software faster and have similar runtime performance. Now we'll look at some of the differences between them. Go, again, is a compiled language, super fast compile times, and compiles to a native executable. C# compiles to cross-platform binaries by default, which need the .NET Core runtime, although one can create native binaries with .NET Native. For readability, Go code has a simpler, minimal syntax. C#, on the other hand, includes a lot of ceremony around .NET development. For example, there are complexities around app and web config that can cause a lot of headaches. For programming type, Go is statically typed multi-paradigm. C# is, for all intents and purposes, a statically typed language and is a type-safe language because it prevents values from one static type from being stored in variables of an incompatible type. It's also an object-oriented programming language with classes. For maturity, Go is a newer language, but it does have a significant community behind it already. Furthermore, everything about Go is new and modern. All existing libraries in Go just work, and Go is written to fit modern standards for development. C# is a more mature language than Go, having been developed around 2000. As such, it has a huge community. So many extensions and community support. C# also supports generics and lambdas. For error handling, again, Go, defer, panic, recover. For C#, C# has a great classic exception handling approach using try, catch, finally. And for memory management, both support memory management like garbage collection. As we discussed, Go has excellent multi-threading capabilities. C# also supports concurrency. And for reflection, Go is a reflective language. And C# is also somewhat reflective in that you perform some level of meta-querying of objects. Now, Go versus JavaScript. Go, again, is a compiled language. JavaScript is just-in-time compiled. It's not really an interpreted language. Very early JavaScript engines were interpreters, but modern JavaScript engines use just-in-time compilation. Think of it this way. At just about the exact time when JavaScript code needs to execute, it gets compiled to executable bytecode. As far as readability, both have a simple, minimal syntax. For programming type, Go is a statically typed multi-paradigm programming language. JavaScript is a dynamically typed language and supports object-oriented, imperative, and functional programming approaches. It is also almost exclusively a web-based language. Maturity-wise, we know Go is a younger language, but still does have a significant community behind it. But JavaScript is older, and with many iterations over the years, it is also one of the most common languages in the world. It has a huge ecosystem to support developers. For example, Node.js gives us thousands of tools and resources with all dependencies conveniently installed and managed using Node Package Manager. In JavaScript, exception handling is built in. In many cases, exceptions will be thrown as you are writing code. JavaScript uses try, catch, throw for runtime error handling, which is well understood and catches errors immediately when encountered. For memory management, both support memory management like garbage collection. For concurrency, Go is excellent. JavaScript, however, is a single-threaded technology, although it does support asynchronous execution by using callbacks, promises, and async and await approaches. It does not, however, support multi-threading concurrency. Reflection is supported with Go. With JavaScript, reflection is supported with meaningful reflection methods.